Now what about solids? Okay, so we've talked about gases, liquids, and we've slowly been making our way to solids. So the particles in a solid are very densely packed. Okay, so you can see here they're quite closely packed and very ordered. That's another key. There's an order to their structure. Whereas before we had like this liquid which was just a bunch of particles just strewn into a space. These ones have an actual physical structure. They're sort of nicely organized. Now there's only enough space for these particles to vibrate, so they can only kind of shake left and right or up and down. Okay, so they can only shake. And particles then occupy only a fixed position. So because they're so close together, they can't swap places with one another. So with liquids and gases, you could have particles sort of interchanging their position. But with solids, because they're so tightly collected, you only have fixed positions for each particle. Okay? Now, due to the fixed position of the particles, solids have a defined volume as well as a defined shape. So because each particle is stuck in one spot, then that substance will have a defined shape. Okay, and that's nice. So if you pour a liquid into a teapot, it will take the shape of a teapot, as Bruce Lee once said in a famous interview. Okay, so it doesn't have a defined shape, nor does a gas have a defined shape. It'll just take the shape of whatever container it's in. But a solid will have a shape, and that is defined by where the particles are in that shape. And as you can see in this diagram, there's an ordered structure again. And if you look very closely, all that's happening is that the particles are kind of just expanding and contracting, and they're just vibrating, okay? They're just opening up and closing. And that's all that can happen in a solid because they're so tightly packed together, okay? They're just vibrating a little bit. Changes in temperature by heat transfer occur rapidly in solids, but slowly in gases. Explain why this is so with reference to the particle theory of matter. So temperature is related to the motion of the particles. So the more particles moving you have, the higher the temperature. So here we have the solid and they're vibrating. That's their method of motion, they vibrate. So temperature is a measure of the kinetic energy of the particles. In order to move that energy, particles need to collide. So in order for this particle to give its energy to the next particle, it needs to interact with it, and they interact by hitting each other. So in a solid, the close spacing means the vibrations caused by one particle can be easily transferred to another particle. So you can see this vibration, this particle vibrating here, can send the vibrations this way. And then this one can vibrate into this one and this one. And you can see the vibrations can be sent very quickly because they're so closely packed together. In a gas, however, the particles are widely spaced, and thus the particles need to travel great distances before interacting with another particle, which obviously takes up time. So you can see that the temperature will move a lot slower, or the temperature change will move much slower because the particles just take longer to interact with each other compared to a solid. Okay?